Deimos is the smaller and outer of the two natural satellites of the planet Mars with a mean radius of 6.2 kilometers, the other being Phobos. Deimos takes 30.3 hours to orbit Mars. The name Deimos is pronounced DY-məs unregistered trademark S, or sometimes DEE-məs unregistered trademark S, or like the Greek II micron II. In Greek mythology, Deimos was the twin brother of Phobos and personified terror. Discovery. Deimos was discovered by Asaph Hall, Sr. at the United States Naval Observatory in Washington, D.C. on August 12, 1877, at about 0748 UTC. Hall also discovered Phobos on August 18, 1877, at about 9:14 Greenwich Mean Time, after deliberately searching for Martian moons. It is named after Deimos, a figure representing dread in Greek mythology. The names, at first spelled Phobos and Deimos, were suggested by Henry Madden, science master of Eton, from Book 15 of the Iliad, where Ares summons dread and fear. Physical characteristics. Deimos, like Mars's other moon, Phobos, has spectra, albedos and densities similar to those of a C or D-type asteroid. Like most bodies of its size, Deimos is highly non-spherical with triaxial dimensions of 15 12.2 11 kilometers, making it 0.56 times the size of Phobos. Deimos is composed of rock-rich in carbonaceous material, much like C-type asteroids and carbonaceous chondrite meteorites. It is cratered, but the surface is noticeably smoother than that of Phobos, caused by the partial filling of craters with regolith. The regolith is highly porous and has a radar estimated density of only 1.471 grams per centimeter 3. The two largest craters, Swift and Voltaire, each measure about 3 kilometers across. It has an escape velocity of 5.6 meters per second and apparent magnitude of 12.45. Named geological features only two geological features on Deimos have been given names. The craters Swift and Voltaire are named after writers who speculated on the existence of two Martian moons before Phobos and Deimos were discovered. Deimos. Orbital characteristics. Deimos's orbit is nearly circular and is close to Mars's equatorial plane. Deimos is possibly an asteroid that was perturbed by Jupiter into an orbit that allowed it to be captured by Mars, though this hypothesis is still controversial and disputed. Both Deimos and Phobos have very circular orbits which lie almost exactly in Mars's equatorial plane, and hence a capture origin requires a mechanism for circularizing the initially highly eccentric orbit, and adjusting its inclination into the equatorial plane, most likely by a combination of atmospheric drag and tidal forces, although it is not clear that sufficient time was available for this to have occurred for Deimos. As seen from Mars, Deimos would have an angular diameter of no more than 2.5 minutes, 1/12 of the width of the Moon as seen from Earth, and would therefore appear almost star-like to the naked eye. At its brightest it would be about as bright as Venus is from Earth. At the first or third quarter phase it would be about as bright as Vega. With a small telescope, a Martian observer could see Deimos's phases, which take 1.2648 days to run their course. Unlike Phobos, which orbits so fast that it actually rises in the west and sets in the east, Deimos rises in the east and sets in the west. However, the Sun's synodic orbital period of Deimos of about 30.4 hours exceeds the Martian solar day of about 24.7 hours by such a small amount that 2.7 days elapse between its rising and setting for an equatorial observer. Because Deimos's orbit is relatively close to Mars and has only a very small inclination to Mars's equator, it cannot be seen from Martian latitudes greater than 82.7 degree. Solar transits Deimos regularly passes in front of the Sun as seen from Mars. It is too small to cause a total eclipse, appearing only as a small black dot moving across the Sun. Its angular diameter is only about 2.5 times the angular diameter of Venus during a transit of Venus from Earth. On March 4, 2004 a transit of Deimos was photographed by Mars rover Opportunity, and on March 13, 2004 a transit was photographed by Mars rover Spirit. Origin. The origin of the Mars's moons is unknown and the hypotheses are controversial. The main hypotheses are that they formed either by capture or by accretion. Because of the similarity to the composition of C or D-type asteroids, one hypothesis is that the moons may be objects captured into Martian orbit from the asteroid belt, with orbits that have been circularized either by atmospheric drag or tidal forces, as capture requires dissipation of energy. The current Martian atmosphere is too thin to capture a Phobos-sized object by atmospheric braking. Jeffrey Landis has pointed out that the capture could have occurred if the original body was a binary asteroid that separated due to tidal forces. The main alternative hypothesis is that the moons accreted in the present position. Another hypothesis is that Mars was once surrounded by many Phobos and Deimos-sized bodies, perhaps ejected into orbit around it by a collision with a planetesimal. Exploration. Overall, its exploration history is similar to those of Mars and of Phobos. Deimos has been photographed in close-up by several spacecraft whose primary mission has been to photograph Mars. No landings on Deimos have been made. Under Soviet Phobos program, Phobos 1 probe with flyby and jumping lander dedicated to Phobos. But in case of success of it, Phobos 2 may be ordered to Deimos. Both probes launched successfully in July 1988. The first was lost en route to Mars, whereas the second returned some data and images but failed shortly before beginning its detailed examination of Phobos' surface, including a lander. In 1997 and 1998, the Aladdin mission was selected as a finalist in the NASA Discovery program. The plan was to visit both Phobos and Deimos, and launch projectiles at the satellites. The probe would collect the ejector as it performed a slow flyby. These samples would be returned to Earth for study 3 years later. The principal investigator was Dr. Carl Peters of Brown University. The total mission cost, including launch vehicle and operations, was $247.7 million. Ultimately, the mission chosen to fly was Messenger, a probe to Mercury. In 2008, NASA Glenn Research Center began studying a Phobos and Deimos sample return mission that would use solar electric propulsion. The study gave rise to the Hall mission concept, a New Frontiers-class mission currently under further study. Also, the sample return mission called Gulliver has been conceptualized and dedicated to Deimos, in which 1 kilogram of material from Deimos would be returned to Earth. Another concept of sample return mission from Phobos and Deimos is OSIRIS-REx-2, which would use heritage from the first OSIRIS-REx. In March 2014, a Discovery-class mission was proposed to place an orbiter on Mars orbit by 2021 and study Phobos and Deimos. It is called Phobos and Deimos and Mars Environment. In fiction, its software's 1993 game Doom has its third set on Deimos. See also: List of natural satellites, List of missions to the moons of Mars, Phobos and Deimos in fiction, Transit of Deimos from Mars. References. External links: Deimos profile by NASA's Solar System Exploration, Deimos rotation movie, animation of Deimos, USGS Deimos nomenclature.